Hello everyone, in this video I will deal with the substitution theorem. So first we will see the statement of this substitution theorem. So what does it state? It states that any branch in the circuit, it can be replaced by an equivalent branch provided that the equivalent branch, it will maintain the same current through the branch or the voltage across the branch, okay, as the original branch. So it states that any branch in the circuit can be replaced by an equivalent branch provided that replaced branch maintains same current through and voltage across it as the original branch. So this is the statement of the substitution theorem. So we will be replacing the branch here, but remember that the behavior of the circuit, it does not change. Okay, behavior of circuit does not change. This is applicable to both linear and non-linear circuits. So in bridge network and all, you will be substituting that V is equal to I is equal to 0 by the short circuit and open circuit branches respectively, right? This is also an example or application, okay? This is an application of substitution theorem. Okay, so let us study this in detail by considering some examples. Okay, so first I will consider a circuit here. 10 volts, this is 4 ohms, and here I will consider a resistor 1 ohm. Okay, so now the thing is, when you are applying the substitution theorem, first you have to find the branch voltages and the branch currents. Okay, you should not alter the circuit, but you should find all these things, and then only we can replace particular element by the combination of the components. Okay, so the terminal voltage and the current, it should be maintained. Okay, it should be maintained as the original branch. So here first I will find out the current. So current can be found out using V divided by R equivalent, right? So that is nothing but here V is equal to 10 divided by R equivalent is 4 plus 1, since they are in series, so it is 5. 10 divided by 5 is nothing but 2 ampere. So the current that is flowing here is 2 ampere. That means now you can find the voltages across the resistors. Since the current is flowing in this direction, I am taking the voltage drop like this. So here it is 4 to 8 volts and here it is 2 into 1, 2 volts. So you can see this is the resistor, 8 plus 2, 10 volts, so 10 volts. Okay, so this is the example. Now what I can do is, I can replace this 1 ohm resistor, okay, by different combination of the components. So first what I will do is, I will replace this with a voltage source. I will replace this with a voltage source. But now we have to see, okay, what will be the resulting circuit. So this one I will write as it is. I am not changing it. This one also 4 ohm I am writing as it is. But now I am replacing this by a voltage source. Okay. So what is the voltage across this? 2 volts. Right. This is 2 volts. So I am replacing this. So now let us see if the current flowing, okay, it is same, resistance is same, everything will be same. See, we will find out the current now. So I will think that this is my unknown now. I don't know the current now. I have to find it out. Okay, so 10 minus V minus 2 is equal to 0. V is equal to 8 volts. Okay, V is equal to 8 volts. So this is my 8 volts then. if the 8 volt is a voltage drop across this resistance, we can find out the current through the resistance. That is voltage divided by resistance, 2 ampere. So 2 ampere is a current. Okay, 2 ampere is a current. So now you can see this resistor. What is the voltage across this? 2 volts. Means across this A and B, what is the voltage? It is 2 volts. And what is the current? 2 amperes. So this is the same thing, right? A and B. What is the voltage? 2 volts. What is the current flowing? 2 ampere. So the voltage and the current, they are maintained same as the original branch. Okay. So now I will replace it with the current source. See, I will keep this as it is, that is 10 volts, and here we have 4 ohms. Okay, now I will replace this with the current source. We know that the 2 ampere current is flowing here, so I will replace with the 2 ampere current source. So now what we have to do, see, this one is 2 ampere, that means the same current is flowing here. So it is plus or minus 8 volts. So what is the voltage across this? We have to find. I will consider this as A and this as B. We have to find V. We have to see whether it is maintained the same thing. Okay. 10 minus 8 minus V is equal to 0. V is equal to 2 volts. So this one is also 2 volts now. See, the current is 2 amperes. Voltage is also 2 volts. So now what I did is, I replaced this resistor with the ideal voltage source here and ideal current source here. Now, I can also use the practical voltage source and the practical current source. Okay, so we will see the third substitution now. That means now the voltage source will be having some resistance. So this is 10 volts as it is. This is 4 ohms as it is. Now what I will do is, I will replace this 1 ohm with, I will replace it with a 2 ohm resistor, and here I should find out the voltage source now. See, it is maintaining the same current 2 ampere. That means 2 ampere, it is here plus or minus 4 volts. So this is plus or minus 8 volts. So to find out the voltage, 10 minus 8 minus 4 minus x is equal to 0. So here 10 minus 8 is 2. 2 minus 4 is minus 2. So minus 2x, x is equal to minus 2 volts. So I can write this as minus and plus 2 volts. Okay, so if I can replace this 1 ohm resistor with this practical voltage source which is having internal resistance 2 ohm, and you have to keep this in mind. Okay, so now if I apply this 10 minus 8, that is 2, 2 minus 4 is minus 2, minus 2 plus 2, that is equal to 0. So it is satisfied, right? And the current is also same. So now we can see 4 and this one 2, since they are in opposite directions, means the polarities are opposite, right? So here we will be taking the difference, that is 2, and what will be the polarity? It will be same as the source which is having the larger magnitude. So 4 volt is larger, so we will have the same direction plus or minus, and then it will be the difference of that 2, plus minus 2 volts. So the voltage is maintained, even the current is maintained. Okay, so similarly, now we can replace it with the practical current source. Okay, now we will see how it is replaced. So this is 10 volts as it is. This is 4 ohms as it is. Here I will replace it with the current source, practical current source. I will take the resistance of 2 ohm once again. Okay, 2 ohm once again. Now we have to find what will be the direction of the current source and what will be the voltage across this. See, you already know this is maintained, right? 2 ampere is maintained. That means here we have 8 volts. Here we should have 2 volts across this, right? To maintain 2 volt across this, the voltage drop across this also is 2 volts. Why? Because these two will be in parallel. Whatever the current source I am going to attach, this and this are in parallel. That means voltage across this combination will be 2 volts. So if this is 2 volts, what will be the current which is flowing through this? It is 1 ampere. The incoming current is 2 ampere. So now at this point, if I apply the KCL, 2 2 ampere is coming, 1 ampere is flowing here. So 1 ampere should flow in this direction. So I will take this as 1 ampere source. Okay, 2 volt is maintained, 2 ampere is also maintained, but now I have replaced this 1 ohm resistor with a practical current source. Okay, practical current source. So this is all about the substitution theorem, like how we are going to substitute the different branches instead of a resistor. Okay, just remember the branch voltage and the branch current, it should be same. It should not be altered. Okay, it should not be altered. So here also it is 2 ampere, 2 volts. 2 ampere is flowing through this branch, 2 volts is maintained. But just we are replacing it with the different combination of the components. First we replaced the resistor with the voltage source, then we replaced it with the ideal current source. Next we took the practical voltage source, and here we took the practical current source. Okay, so now we will take this example and we will solve. Asking us to replace this particular box, this section, okay, that is 60 ohm section, using a current source and 240 ohm resistance. That means practical current source is asked. Okay, we have to replace this particular branch. That means we have to find the value of the current. Now we have to find the voltage also, because that should be maintained constant. And this circuit, it will be unaltered. This is 20 volts, right? This is 20 volts. Yes, this is 20 volts. So now we will find out the current. Okay, so to find out this current, we can use the nodal analysis. We can also convert this voltage source to the current source. So first we will convert the voltage source to current source. So this is 20 divided by 16, and here we have 16 parallel 40, and here we have 60 ohm. This is the current I. Okay, so the resistance, and here this is the current. So what is this I? From the current divider rule, I can get 20 by 16 into 16 parallel 40 divided by 16 parallel 40 plus 60. Okay, so if you solve this, you will be getting it as 200 milliampere. Solve this, you'll be getting 200 milliampere. So now we know the current 200 milliampere. Okay, so what is the voltage across the combination? It will be 200 into 10 to the power of minus 3 into 60. So that means 12 volts, right? Voltage will be 12 volts. This voltage, it will be 12 volts. This is 200 milliamperes. Now, we will replace that with a current source. I will keep the circuit as it is. Now what we got to know? This is 200 milliampere, right? So now we have to replace it with the current source and a resistance. We know the value of resistance 240 ohm, but we don't know in which direction we should place our current source. Okay, so that only we will find it out. So 200 milliampere is entering. We already know the voltage is 12 volts. So if this is 12 volts, that means the voltage across this, voltage across the current source, that is also 12 volts. So 12 divided by 240 will be the current through this 240 ohm resistor. Voltage divided by resistance. So this one will be 1 by 20. So this will be 50 milliampere, right? So the current through this is 50 milliampere. If the 200 milliampere is coming, 50 is divided here. So 150 will be coming from this side if I apply the KCL. So this is 150 milliampere. So this is what they have asked, to replace this particular branch with a current source and a resistor. So I have replaced it. I have replaced this branch now. See, this is 150 milliampere current. This is the 240 ohm resistor. Okay, so this was all about the example. Now we will also see what is this back substitution. Okay, back substitution. That means now we studied how we will be replacing a resistance by the voltage of the current source. Similarly, we can also replace the current of the voltage source by a resistance. Okay, let us see that. See, in whichever examples I told you, we have replaced the, see, this was the resistor, right? So we replaced this. It was the 2 ampere which was the current flowing here. This was 1 ohm. Okay, so we replaced it with the 2 volts source, 2 volt source, and this was 2 ampere, right? So it was the first example which I dealt with. So this was the replacement of this particular resistor, and also we replaced this with the 2 ampere, and we had plus or minus 2 volts, right? This is 2 ampere. I replaced this with the current source also. So in this case, you can see that 2 volt, the 2 ampere is entering it. That means this voltage source, it is absorbing power, right? This is absorbing power because the current is entering the positive terminal. This is absorbing power. And see here, the current source, this current is entering the positive terminal once again. That means the current source is also absorbing power. So this was the main thing that we have to notice, okay, while we were using the substitution theorem. That is, while replacing the resistance with the voltage source or the current source. Okay, we have replaced it with the voltage and the current source, and in both the cases they are absorbing powers. Okay, so that is what we have to take care by using this back substitution theorem. So I have considered this example now. We have to find out this back substitution theorem or the reverse substitution theorem. Okay, this is also called as reverse substitution also. So in this case, what we are going to do, we are going to convert this voltage source to resistance, and here instead of current source, we will consider a resistance. And we will see like how it can be done. So we have already seen the substitution theorem, and now here we can see what is the current. Okay, what is the current? So it is, if I assume this as current, so it is 10 minus 4i minus 2 is equal to 0, 4i is equal to 8, I is equal to 2 ampere. So this is the current which is flowing. Okay, so now across this branch, this is the 2 ampere current flowing. We can see that this is absorbing power once again. That is, the voltage source is absorbing power because the current is entering the positive terminal. So resistance will be equal to voltage divided by current. So that is equal to 2 divided by 2, that is equal to 1 ohm. Now I can replace this branch by 1 ohm resistor. Okay, so 1 ohm resistor. This is 4 ohm, this is 1 ohm. This is 10 volts. So now after replacing this, let us check what will happen. So we can see the current is nothing but 10 divided by 5, 2 ampere. So the 2 ampere current, this is satisfied. What will be the voltage? Since the current is flowing in this direction, we will have the voltage drop like this, 2 into 1, 2 volts. See, 2 volts, it is same thing, 2 volts and 2 ampere current. So we can substitute this. That is, instead of voltage source, now we can have a resistance. Similarly, in this case, we will see what happens. So here, let us consider this. This will be the 4 to 8 volts, right? This is 8 volts. So 10 minus 8, and remaining, obviously this should be plus minus. If I consider, this is V is equal to 2 volts. So this will be 2 volts, right? If I apply the KVL, I will be getting this 2 volts. So you can see this current, it is entering the positive terminal. That means this current source is once again absorbing the power. So now we can replace this. So this is the terminals AB. So what I will do is I will find out the resistance now, that is voltage divided by current. So 2 divided by 2, once again it is 1 ohm resistor. So I can replace this branch by 1 ohm resistor. 10 volts, 4 ohms, and here I am replacing it with 1 ohm resistor. Now let us see the terminal voltage and the current. So the current will be 10 divided by 5, 2 ampere. What will be the voltage? 2 volts. So 2 volts and 2 amperes, it is the same as the original branch. So this also can be replaced by this circuit. Okay, that means the reverse substitution is possible in this case when the sources are absorbing power. if we take some examples where the source is delivering power, in that case it will be very difficult to apply this reverse substitution theorem. So I will give you an example. I'll take the same thing, 10 volts. Okay, I'll take 4 ohms. Here I will take something like 20 volts. Okay, 20 volts. So now what will happen? You will find the current here. Okay, you will find the current. So how you will find the current? 10 minus 4i minus 20 is equal to 0. That means 10 is equal to, so minus 10 is equal to 4i. I is equal to minus 5 divided by 2. That is, I is equal to minus 5 by 2 means the current is actually flowing in this direction. Okay, current is actually flowing in this direction. So you will have the voltage drop like this. So that will be 10 volts. Okay, that will be 10 volts. So now this one is 5 by 2, this one is 20. Now you can see that this voltage source is delivering power. It is delivering power because the current is leaving the positive terminal. So if I want to find the value of resistance, what will happen? V divided by I. So 20 divided by 5 by 2. So this one will be 8 ohms, right? 8 ohms. So if I replace this now, what will happen? Let us check. 4 ohm, this is 8 ohm. Now I will find out the terminal voltage. This voltage across 8 ohm, it should be 20 volts actually, right? That is what back substitution theorem is. But here you can see 10 into 8 divided by 10 into 8 divided by 8 plus 4, that is 12. So 4 3s are 4 2s are 20 by 3. 20 by 3 is the voltage that is across 8 ohm. But what is the voltage? 20 volt. So it is violated. So now here this is delivering power. So we can't replace this with the equivalent resistance. That is not possible because you saw what is the value of the voltage? 20 by 3. What is the actual voltage? It is 20 volts. Similarly, for the current source also, if it is delivering power, we cannot replace it with a resistance because it will be violating everything. It will not maintain the voltage or the current through that particular branch as the original branch. But if it is absorbing power like this, okay, both are absorbing power, we can replace it with the equivalent resistance. So this is all about the substitution and the back substitution or the reverse substitution theorem.